scientists have made a groundbreaking discovery. An Earth-like planet located relatively close to our solar system, at least in cosmic terms. This planet, which is the closest of its kind to us, represents the most significant astronomical find in over 2 decades. What makes this discovery so extraordinary is the possibility that this planet could sustain life. Among the many celestial bodies in our solar system, one of the most intriguing is Europa, one of Jupiter's 4 largest moons. Europa is roughly the same size as Earth's moon, but its appearance is strikingly different. Its surface is smooth, bright, and white, crisscrossed with dark cracks and reddish patches that hint at the complex processes occurring beneath its icy exterior. What makes Europa so fascinating to scientists is the strong evidence suggesting that it harbors a vast, global ocean beneath its thick icy crust. In fact, this ocean is believed to contain twice as much water as all of Earth's oceans combined. The presence of a salty ocean in contact with a rocky core, combined with potential energy sources, creates an environment that could support life. If life exists on Europa, it is likely to be microbial, but the implications of such a discovery would be profound. NASA and other scientific organizations are particularly interested in detecting organic molecules on Europa, as these are the building blocks of life. The key question is whether liquid water exists beneath the ice, and if so, whether it could provide a habitat for living organisms. The age-old question of whether we are alone in the universe has captivated humanity for centuries. Now, with the Europa Clipper mission, scientists are taking a significant step toward answering this question. The mission aims to explore Europa in unprecedented detail, focusing on the possibility that its subsurface ocean could harbor life. The presence of water is a critical factor in the search for life, and Europa's ocean, which contains twice the volume of seawater found on Earth, makes it one of the most promising candidates in our solar system. Recent scientific findings have further fueled excitement about Europa. Data from a magnetometer revealed a magnetic signature that strongly suggests the presence of a salty ocean beneath the moon's icy shell. This discovery has profound implications, as it raises the possibility that life could exist beyond Earth. Europa, one of Jupiter's many moons, has long been a subject of fascination for astronomers and planetary scientists. Discovered in 1610 by Galileo Galilei, Europa is part of a group of 4 large moons known as the Galilean satellites. These moons, along with Jupiter, are often referred to as a miniature solar system due to their diverse and dynamic characteristics. Each of Jupiter's moons has unique features that make it a compelling target for scientific study. For example, Io is known for its intense volcanic activity, while Ganymede boasts vast methane lakes. Europa, however, stands out because of its potential to host life. The upcoming JUICE, Jupiter Icy Moons Explorer mission, led by the European Space Agency, will focus on studying Europa and its neighboring moons in detail. The mission's primary goal is to search for water and assess the potential for life on these icy worlds. Water is essential for life as we know it. It serves as a solvent for nutrients, facilitates chemical reactions, and provides a medium for waste disposal. On Earth, wherever we find water, we find life. This principle drives the search for water on other celestial bodies, including Europa. Evidence from telescopic observations and space missions suggests that Europa's icy surface conceals a liquid ocean. This evidence is supported by similarities between Europa's surface features and ice formations found in Greenland. On Earth, double ice ridges and cracks are often caused by the presence of water beneath the ice. Scientists believe that similar processes may be at work on Europa, where the icy crust is thought to be in constant motion. Chemical analysis of Europa's surface has revealed the presence of elements necessary for life, such as magnesium and salts. These elements are likely brought to the surface by geological activity, including possible volcanic processes. The reddish patches observed on Europa's surface are thought to be deposits of magnesium salts, which could indicate interactions between the ocean and the rocky core. On Earth, similar deposits are found in regions with volcanic activity, further supporting the idea that Europa's ocean is dynamic and chemically rich. One of the key challenges in assessing Europa's potential to support life is determining the source of energy that could drive biological processes. On Earth, the sun is the primary source of energy, but Europa is much farther from the Sun, receiving only a fraction of the sunlight that reaches our planet. However, scientists believe that Jupiter's intense radiation could provide an alternative energy source. As Europa orbits Jupiter, the planet's powerful magnetic field bombards the Moon with radiation, which may interact with the icy surface to produce oxygen. This oxygen could then seep into the subsurface ocean, providing a potential energy source for microbial life. The possibility of life on Europa is not limited to oxygen-dependent organisms. On Earth, anaerobic organisms thrive in environments without oxygen, and similar life forms could exist on Europa. In fact, anaerobic bacteria were among the earliest forms of life on Earth, dominating the planet's ecosystems for billions of years before oxygen-producing organisms emerged. If Europa's ocean contains hydrothermal vents similar to those found on Earth's ocean floor, these environments could support a wide range of microbial life. Hydrothermal vents are known to host diverse ecosystems, including bacteria, archaea, and even complex organisms like tubeworms and crabs. The surface of Europa itself provides clues about the Moon's internal dynamics. Unlike other icy moons in the solar system, Europa's surface is remarkably smooth, with few large impact craters. This suggests that the icy crust is relatively young and constantly being reshaped by geological processes. The dark cracks and ridges observed on Europa's surface are thought to be the result of tidal forces exerted by Jupiter's gravity. These forces cause the icy crust to flex and fracture, allowing warmer ice or liquid water to rise to the surface. In some cases, this activity may result in the formation of geysers, which have been observed erupting from Europa's surface. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, provided some of the most compelling evidence for a subsurface ocean on Europa. During its mission, Galileo detected a magnetic anomaly near Europa that could only be explained by the presence of a conductive layer beneath the ice, most likely a salty ocean. This discovery revolutionized our understanding of Europa and paved the way for future missions to explore this enigmatic moon. Building on the findings from Galileo, scientists have continued to study Europa using ground-based telescopes and advanced computer models. Recent observations of Antarctica's ice shelves have revealed a type of low-density snow that forms beneath the ice. This upside-down snow is thought to occur on Europa as well, where it could contribute to the formation of unique geological features. Additionally, the detection of water plumes erupting from Europa's surface has provided further evidence of a dynamic and active ocean beneath the ice. The Europa Clipper mission, scheduled to launch in 2024, represents the next major step in the exploration of this fascinating moon. Equipped with a suite of advanced scientific instruments, the spacecraft will conduct multiple flybys of Europa, gathering data on its surface, subsurface, and atmosphere. Key objectives of the mission include mapping the thickness of the icy crust, searching for signs of recent geological activity, and analyzing the composition of any plumes or surface deposits. The mission will also carry a magnetometer to study Europa's magnetic field and a radar instrument to probe the structure of the ice shell. One of the most exciting aspects of the Europa Clipper mission is the possibility of sampling material from the Moon's plumes. If the spacecraft can fly through a plume and collect particles, scientists may be able to analyze the chemical composition of Europa's ocean without needing to drill through the ice. This would provide invaluable insights into the Moon's potential to support life. As we await the launch of the Europa Clipper mission, scientists are already planning future missions to explore Europa in even greater detail. One proposed mission involves landing a robotic probe on the Moon's surface to study the ice and search for signs of life. Such a mission would face significant technical challenges, including the need to penetrate Europa's thick ice shell and withstand the harsh radiation environment around Jupiter. However, the potential rewards are immense, as the discovery of life beyond Earth would fundamentally change our understanding of the universe.